For decades around the world, electricity has been produced in large centralised power stations and then distributed to users, households, buildings and businesses. In many markets, most of this electricity comes from burning coal, a very inefficient process which produces large amounts of carbon dioxide and other greenhouse gases. Improvements in technology mean that today there are other options for electricity consumers.
This is BlueGen, our mini power station. BlueGen converts natural gas into electricity and heat. The electricity is used to power the home, and excess can be sold back to the grid. The heat makes enough hot water for an average family home every single day.
As a result of many years of research and development and an investment of more than $250 million, Melbourne-based Ceramic Fuel Cells is providing users of electricity worldwide with an alternative to produce their own electricity from natural gas in their own homes or businesses.
About the size of a dishwasher, the BlueGen unit converts natural gas to electricity and heat. Inside BlueGen is a stack of ceramic fuel cells. Natural gas and air go into the fuel cells and a high temperature chemical reaction converts them into electricity and heat. The heat is enough to produce 200 litres of hot water a day, and importantly, much lower carbon emissions.
The most compelling reason is the environmental benefits that the technology generates. Huge carbon savings, here in Australia up to 18 tonnes, in Europe 3 to 5 tonnes of CO2 per year per unit. Compelling financial returns are available for people that own the units, so we think that's an attractive proposition.
Importantly, BlueGen produces electricity at a much greater efficiency than the current power grid. Governments in many large markets, including Germany, the United Kingdom, France and Japan, have seen the benefits and are actively encouraging the purchase of these units.
Brown coal is delivered to the household at an efficiency of less than 25%. BlueGen's at about 60%, brown coal less than 25% electrical efficiency.
Over the course of a year, each BlueGen unit can produce up to 17,000 kilowatt hours of power. That's more than twice the electricity needed to power an average home. In commercial volumes, BlueGen can produce electricity at a lower cost than conventional power stations, with significant savings on the average home's annual energy bill.
People who are living in larger houses, larger homes or multi-dwelling buildings will be able to use most of the power within the building and enjoy the savings of offsetting retail cost electricity. But energy exported back to the grid does have a good financial return for owners of BlueGen.
Today, Ceramic Fuel Cells employs 90 people, including 60 scientists and engineers. The company is developing products with leading international appliance partners and utility customers.
Well, we've already got units running in the United Kingdom, in France, in Germany. We expect to have units running in Japan very soon. The latter half of 2010 should see the launch of the product in the United States. And in the not too distant future, the product will be generally available to the public here in Australia.
As the world looks to reduce carbon emissions significantly and as homeowners want greater options to get involved, BlueGen's importance is growing. BlueGen improves the use of existing fossil fuels and increases the efficiency of existing power grids and networks. These are significant markets. The replacement market for boilers and heating systems in the European community alone is more than 8 million units a year.
Units will ultimately cost substantially less than solar. The units will give you a financial return far before you'll get a financial return with solar PV. And finally, the carbon benefits that this unit generates are far in excess of those that solar PV will generate, simply because we offset more electricity from existing generating sources.
Over the next few years, governments across the world will spend billions of dollars each year on network upgrades and the reinforcing of existing infrastructure. The adoption of BlueGen technology, where electricity is produced at the point of use, can avoid much of that spend. A study recently completed for the UK government determined there was the potential in the UK for millions of small-scale generators, including fuel cell units like BlueGen.